Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study and solve some of the problems on Macaulay's method. So, here, a beam of 6 meters is simply supported at its ends and carries a point loads of 48 kilonewtons and 40 kilonewtons at a distance of 1 meters and 3 meters respectively from the left support. So here, what are the objectives are to be found? That is, number one, deflection under each load, and number two, okay, the second value is here, maximum deflection, and third objective is here, the point at which maximum deflection occurs. So the input parameters here given, that is, one is the load, another one is properties of the material, that is E equal to 2 into 10 power 5 Newton per square millimeter, that is modulus of elasticity, and another one is here, that is area moment of inertia, that is 85 into 10 power 6 millimeter per 4. If you draw the diagram, it is simply supported at A and B. The length of the span of the beam is here 6 meters. Point loads 48 kilonewtons at a distance of 1 meter, and another load is acting 40 kilonewtons at a distance of 3 meters. Under these conditions, we have to find out, consider C and D, find out the slope and deflections under these point loads, okay, and also maximum deflection and the point at which the maximum deflection occurs. These are the three objectives are in front of us. Let us begin. First, we have to calculate the reactions at supports A and B. The calculated reactions by using the concepts of shear force and bending moment diagrams concept, we have to find out the support reactions. How to find out support reactions? Yes, as a glimpse, let us see here. Sigma Fy equal to 0 and sigma m equal to 0. So by considering these two equations, this is sigma m here, taking moments about A equal to 0, then we'll get it both on Ra plus Rb, sum of reactions. Ra plus Rb equal to 48 plus 40, that is 88 kilonewtons. Now, by using these two equations, we can find out the support reactions at A and B. So Ra is calculated here, it is 60 kilonewtons. Rb is as 28 kilonewtons. Now the equation, the section, we have to write the momentum equation, bending moment equation, various the bending moment that is considered here between points D and B. Such a way that that equation involves the part of A to C and A to D and also total AB. Now that equation here it is Ei times d square y by dx square equal to Ra times x minus 48 times x minus 1 minus 40 times x minus 3. What is the Ra value here? The reaction at A is 60 kilonewton. Substitute here 60 kilonewton, that is 60 times x minus 48 times x minus 1 minus 40 times x minus 3. So this equation, if you want throughout the span of the beam from left support up to support B, then we have to use the total partitions, partition 1, partition 2 and partition 3, sum of these three total equation. But if you require between up to point C, then we have to use variation of the slope and deflection up to 60x, up to part 1. And we want that from D to B, C to D, from A to D we need. Then 60x minus 48 times x minus 1 we have to consider. So now for this equation, if you integrate first once, then that equation is transferred to a slope equation. Transform it to a slope equation, that EI times dy by dx equal to 60 times x square by 2 plus C1. That is a methodology. We have to add constant of integration for the first part only. Minus 48 times x minus 1 whole square by 2. Minus 40 times x minus 3 whole square by 2. Now this is the equation simplifying 60 by 2, that is 30 times x square plus C1 minus 24, that is 24 times x minus 1 square minus 40 and 2, that is 20, minus 20 times x minus 3 whole square, that is EI times dy by dx. Now integrate the slope equation, that one, then we'll get it the deflection equation with the two constants of integrations, that is EI times y equal to 30 times x square integration, that is x cube by 3 plus C1 integration C1 times x plus C2 minus 24 times x minus 1 whole square, that is x minus 1 whole cube by 3. This x minus 3 whole square, that is 20 times x minus 3 whole cube by 3. Now this is 10 times 30 by 3, 10x cube plus C1x plus C2 minus 8 times x minus 1 whole cube minus 20 by 3 x minus 3 whole cube. This is EI times y. If we know the constant of integrations, after substituting those constants of integrations C1 and C2, if we substitute C1 and C2 in equation 2, that equation becomes the deflection equation. And if we calculate C1 in equation 1, that equation becomes the deflection slope equation. Now how to find out these two constant of integrations? By using two boundary conditions. The two boundary conditions are x equal to 0, y equal to 0 at x equal to L. L means what? Throughout the span, that is x equal to 6 meters, the deflection is 0. Substitute these two conditions in where y means y stand for deflection. So what is that equation number? That is equation number 2. Substitute this equation number 2, those two boundary conditions. Then the value of C1 and C2 are obtained. What is the C2 value? Becomes 0 and C1 becomes 160 minus negative of 163.33. Substitute this C1 and the C2 in equation 2. Now you get it. This is the equation. Equation 2 becomes equation 3 after substitution of C1 and C2. This equation, if you substitute the x value from x equal to 0 at the support, yes, now at x equal to 0 from left side support, from x equal to 0, that at support A, up to x equal to 1, up to first partition, y equal to 10x cube minus 163.33x. If x equal to up to 3, then you have to consider up to x equal to 6, we have to consider 3 parts completely. Now where we want, this is the equation, we got it. This is the deflection. We did not go for slope equation. Why we did not go for slope equation in this part? Anybody? Because one thing, what are the objectives? The objectives are only deflections only. There is no slope. That's why we derived the deflection equation. Yes, this is the deflection equation. In this deflection equation, what is the first objective? The first objective is the deflection under the first load, that is at point C. That is at point C. This is obtained by substituting x equal to 1. But how much portion we have to consider? The portion should be this much. We have to consider the first portion. y equal to 10x cube minus 163.33 times x. Substitute x equal to 1 here. Then it becomes 10 minus 163.33. And then it becomes minus 153.33 kilonewtons meter cube. Now convert into newtons and millimeters, so that because E and I values are in Newton per square millimeters category, that's why we made it into Newton millimeter cube. That is minus negative of 153.33 times 10 power 12 Newton millimeter cube. Then Yc equal to how much? E and I value substitute here. The E value is 2 into 10 power 5 and I value is 85 times 10 power 6. And substituting, then it is derived. How much it is obtained here? The deflection at point C is negative of 9.019 millimeters. Okay, next. We want next one. What is the deflection under second load? What is the second load here? At a distance x equal to 3. Substitute in this equation x equal to 3. But how much we have to consider? The portions, first part and second part summation. This is the portion you have to consider. Now that is 10x cube minus 163.33 times x minus 8 times x minus 1 whole cube. Where x equal to what? X equal to 3, substitute here. Then, and substitute E and Y, convert it into Newton millimeters. So that the derived is that minus 16.7 millimeters. At C, 9.019. At C, the deflection Yc is 9.019 millimeters. At D, that is 16.7 millimeters. That means, but C and D, if we compare among between two, the maximum deflection occurred here at D. Now we want maximum deflection, but how can we know maximum deflection? Between 2 points applied load, we consider that at D, and here at C and D, the D is the maximum deflection, that is negative 16. That means negative value indicates downward direction. Alright, now we want the value where maximum deflection location we need. After calculating the location, we have to substitute that x value in the deflection equation, then we will get it the maximum deflection at that point. So what is the x value where? Let us see. So the deflection is likely to be maximum, okay, section between C and D. Then for maximum deflection, what will happen? Dy by dx should be 0. Slope is 0 for maximum deflection. So what is the slope? Equal to 0 wherever this is the thumb rule, please. Not thumb rule. Suppose the maximum deflection occurred at the point load. Here what is the slope? 0. But here y maximum. So under maximum deflection, the slope is 0. Hence, what we are going to do, equation 1 and substituting a C1 value in that equation 1 and making 0. So, the C1 value we calculated as negative value of 163.33, that is 30 times x square minus 163.33 minus 24 times x minus 1 whole square equal to 0. X minus 1 whole square means x square plus 1 minus 2x, that is a minus b whole square. Now 30 times x square minus 163.33 minus 24x minus 24x square minus 24 minus into minus plus, that is 48 times x. Now after simplification, we will get this x value. This is ax square plus bx plus c. So when the equation is in the form of ax square plus bx plus c equal to 0, the units can be derived, that is minus b plus or minus b square minus 4ac by 2a. So by using the formula, we can find out the value of the x. So by using this minus negative 48 minus b, what is a here? From this, a equal to 6, b equal to 48, c equal to negative value of 187.33. Substitute this a, b, c here in this formula and we'll get x value. The x value is derived as 2.87 meters. 2.87 meters. Okay, so we got it as between C and D. How much it is? 2.87 meters. Substitute this 2.87 meters in the value of one of the equation, in the above equations. then we'll get it how much? The negative value, that is minus 16.745 millimeters. This is the Y maximum. But at the D, YD, what is the YD value? Nice, negative 16.7. At the C, 9.019. So the maximum difference is that more here. The maximum deflection at the distance of 2.87 meters, at 2.87 meters from X, the 0.045 is more in comparison to the deflection at D. So here the maximum deflection is occurring at a distance of 2.87 meters. Okay. Now this is the problem in this. We calculated the deflection at applied loads where the loads are occurred. Here the loads are at point C and point D, and also calculated the maximum deflection. But the methodology we followed, how? The methodology followed by the Macaulay's method. So we derived the generic bending moment equation, derived the slope equation, and substituted the values of X wherever we required. In this problem, yes, one more thing. In this equation, if you substitute X equal to 6, then we have to consider the 3 points, even though they did not ask here. At support B, what is the YB? X equal to 6, if we substitute here, what will happen? We'll see. I times Y, 10 into 6 cube, minus 163.33 times 6, minus 8 into 6 minus 1 whole cube, minus 20 by 3, 6 minus 3 whole cube. Let's you see what will happen here. At support, we want X equal to C, means it is YB comes, and find out what is that. But it should come how much? The value of 0. Because at support, the deflection becomes 0. How we got it at support A? Suppose if you want at support A, what is the support A? At X equal to 0. First part we consider at support A, that comes X equal to 0 means at support A, that is YA equal to X equal to 0. Consider in the first portion, that is 10 into 0 cube minus 163.33 times 0. Then the deflection at support A is 0. Similarly, if you substitute at X equal to 6, at support B, the value should come 0. If it is not 0, there is a problem, lacuna in the equation. Alright, that is the validation of deflection equations. Okay, alright. This is the methodology. In this manner we have to solve the deflections at the applied loads at C and D by using Macaulay's method. Now, some of the problems we'll consider in Macaulay's method here. Now, this is here, in this case, a beam of length 8 meters. A beam of length here it is 8 meters is simply supported at its ends. We are considering only simply supported beam with various types of loads. It carries a uniformly distributed load of how much? 40 kilonewtons per meter. We need to find out the deflection of the beam at the midpoint, and also the position of maximum deflection. Yes, position of maximum deflection and maximum deflection, and that means value of the maximum deflection. The properties of modulus of velocity and second moment of area values are given here are 2 into 10 power 5 Newton per square millimeter, and the I value is 4.3 into 10 power 8 millimeter per 4. So this is the diagram was given here. Diagram is given here. So how to find out? First part, calculate RA and RB. by using the equilibrium equation sigma Fy equal to 0, sigma Ma equal to 0. Alright. Now what is that those values are? Reactions at A and reactions at B. So here the length of the span of the beam is 8 meters and UDL, small w actually, this total load mentioned here, small w is 40 kilonewtons per meter, and modulus of elasticity of the material is 2 into 10 power 5 Newton per square millimeter, and modulus of elasticity, second moment of inertia is 4.3 into 10 power 8 millimeter per 4. Now take moments about A, that is RB into 8 equal to, what happened here, 40 into 4, that is 160, plus 1 plus half of the distance, 1 plus 2, 3. So 40 into 4 into 1 plus 3, 1 plus 2, 3 meters, that is 480. RB calculate, RB equal to 60 kilonewtons, and RA equal to total load minus RB. What is the total load here? 40 into 4, that is 160 minus 60, 100 kilonewtons. So RB is 60 kilonewtons. The value of the RB is 60 kilonewtons and RA equal to 100 kilonewtons. We calculated here. After calculating, we have to consider, we have to write down the equation, bending moment equation from left support. So we consider bending moment equation from left support such a way that it includes all parts, all variations, I mean A to C, C to D and also D to B. So consider the distance x from the left support, and write down the bending moment equation. In that bending moment equation, you have to equate that bending moment equation to the bending moment equation variation at any section, that is EI times d square y by dx square. That equation, if you integrate once, that equation being deflection, slope equation, and integrating the slope equation, the deflection equation can be obtained. And in the deflection equation, there are two constants of integrations. Those integrations constants to be calculated by using two boundary conditions. Let us begin. This is the equation EI times d square by dx square. We consider x, distance from end A. Now point is that here this uniformly distributed load is missing between D to B. So in this problem, what we consider, for simplifying, we consider top 40 kilonewton per meter, bottom also 40 kilonewtons. That's why this top and bottom will be cancelled. So there is no effect. For that equation, RA into x, that is 100 times x minus negative of 40 times x minus 1 times x minus 1 by 2 plus 40 times x minus 5 into x minus 5 by 2. Now, this simplification if we do here, substitute RA, that is 100 times x, 40 times x minus 1, any distance if we consider x minus 1, yes. Now, EI, this is the equation. If you integrate once, that the deflection slope equation, the slope equation EI times dy by dx equal to 100 times x square by 2 plus C1 minus 20 times x minus 1 whole cube by 3 plus 20 times x minus 5 whole cube by 3. This is the slope equation. Then integrate the slope equation again, then you will get the deflection equation. EI times y, that is 50 times x cube by 3 plus C1x plus C2 negative of minus 5 by 3 x minus 1 whole 4 power 4 plus 5 by 3 x minus 5 power 4. This is the which equation? Deflection equation. In this deflection equation, there are two constants of integrations are there. These two constants of integrations are to be calculated by using two boundary conditions. The boundary conditions are x equal to 0 and at x equal to 0, the deflection is 0. At x equal to 8 meters, the deflection at support B, that is also 0, deflection. So we have to substitute, we have to use these two boundary conditions and substitute in this equation of 2, in the equation 2. Now, substitute boundary condition here, x equal to 0 and y equal to 0, then C2 becomes 0. Then if you substitute second boundary condition, that's C1, but is negative value of minus 583.33. Substitute C1 and C2 in equation 2 again. That equation gives the deflection equation, that is EIY equal to 50 by x cube, 50 by 3 x cube minus 583.33 times x minus 5 by 3 x minus 1 whole power 4 plus 5 by 3 x minus 5 power 4. Alright. Now, that equation, in that equation, substitute x equal to deflection at the center. What is the deflection at the center? This is 1 plus 4, 5 plus 3, 8. 8 by 2, 4 meters. X equal to 4 substitute at the center will come. That center, the value, that is 16.29 millimeters. Here, why we have done here? This, in this equation, all are in kilonewtons. That's why kilonewton millimeter cube we got. That kilonewtons meter cube should be converted into Newton millimeter cube. So that Newton is 1 kilonewton equal to 1000 newtons. 1 millimeter cube, 1 meter cube means what? 1 meter equal to 1000 millimeters. 1 cubic meter, that means 1000 cubic millimeter cube. That is 10 power 9 millimeter cube. That's right. Now, E and I are in Newton per square millimeter. I value in millimeter power 4. Substituting here, then we got it as Y, that equal to, at its center, Y at center is 16.29 millimeters downwards. Now, next, the position of maximum deflection. We want the position where it is. What is the position of the maximum deflection? We have to make it dy by dx. Maximum deflection where the slope equal to 0. So substitute C1, equation 1, that is C1 value, and equal to 0, then you derive it x value. Here, how to find out in this x value? This is, it is not in the form of 583.33 minus 6.667 x minus 1 whole cube. So this is in cubic polynomial. So it is not in the form of quadratic equation, such a way that we can use the formula when the quadratic, it is in the form of quadratic ax square plus bx plus c. Then we can derive the units of x, the value of x, by substituting in this problem minus b plus or minus b square minus 4ac by 2a and the square root of b square minus 4ac by 2a. But here it is not. This equation is cubic. How to go for it? How to calculate the value of the x? We have to go for method is called trial and error method. So substitute x equal to 1 such a way that we will get LHS equal to 0. So by substituting x equal to 1, we got the value of minus 533.33. And if we substitute x equal to 2, then the value came minus 390. X equal to 3, minus 136. X equal to 4, we crossed the border from negative to positive value. So that means it is in between 3 to 4 x value. So there again you have to make it first x equal to, we have to go for 3.5 like that. So here the value is calculated at 3.82 and 3.83. So 3.83 become closer to 0 value, negative 0.99. Now we considered this 3.83 is the where? The maximum deflection location. That at a distance of 3.83 meters from left support, then their maximum deflection is observed. Now substitute this is the value of location, position of maximum deflection 3.83 meters from support A. Now substitute this 3.83 meters where we have to substitute the generic equation of the slope. This 3.83, where it is location, now understand. From left support to here, 3.83 from support here, between C and D. We have to consider CD parts, means part 1 and part 2 we have to consider and substitute this 3.83. Alright? Yes, we consider part 1 and part 2. What is the part 1 here in this equation? Up to this portion we have to consider because it is between C and D, I think so. Yeah, between CD, the CD portion is part 1 and part 2 we have to consider, not two other parts. Now we consider the part 1 and part 2, CD beam. Now up to second dotted line we consider substituted value x equal to 3.83 meters. And we got it the value of negative of 16.33 millimeters. Okay, 16.33 millimeters. This is the maximum deflection value. The maximum deflection is calculated. So in this session we calculated, okay, the value by using the value of slope and deflections by using Macaulay's method, and solve the problems of when two types of loads, point concentric loads are acting at a distances, or this is nothing but eccentric loads are acting at a distance of 1 meter and 3 meters from left supports. And one more problem is that uniformly distributed load is acting on a simply supported beam, and we have calculated the maximum deflection and also location of maximum deflection, and we calculated the value of the maximum deflection at the midpoint of the beam, that is here 4 meters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.